Hello, this is Murphy with my second video for section 1.1, Analyzing Categorical Data in AP Statistics. The first video had us looking at some graphs and how they did a poor job, like graphs done wrong. This time we're actually going to look at some graphs that are done right. We're going to go over some like vocab and look at different types of graphs, how to make them, and we'll look at some good visuals and data along the way. Whoop, let's try that again. So, for starters, let's define a little bit of terminology. Just focus on the left side of the screen for a moment. So if I have a distribution of data that tells us two things, it tells us what a variable's values are, like what their outcomes could be. I think in the last video I talked already about categorical versus quantitative. Quantitative is just number stuff, like, I don't know, age in years or like annual income in dollars, number of children someone has, the daily temperature in a location, house prices, miles driven to work, whatever. If the outcome's a number, it's quantitative, root word quantity, as opposed to categorical, which is just anything that's, not number, some kind of words, like what state you're from, what your marital status is, your blood type, political party affiliation, anything like that. It's pretty straightforward, except in some tricky situations where it could be one or the other. For example, like if I ask the distribution of students' grades, you could say 9, 10, 11, 12, which would be quantitative, or you could say freshman, sophomore, junior, senior, which would be categorical. That doesn't matter too much. It's just whichever one of these two things it falls in between really dictates what type of graph we're going to use. So as long as you stick to a thing and roll with it, you're fine. So again, a distribution is two things. It's the values that a variable takes, and it's also how frequently those values occur. We can measure that in two ways. One is the raw frequency, which is just the straight up number of counts, the number of occurrences. The other is the relative frequency, which if we speak relatively, that tells us essentially, counts individuals. The relative frequency tells us the percents of the total. How do I find that? So for example, now we can peek onto the right side. Legos is a fun thing to be. So it's kind of a random context here and also like very aesthetically appealing. There's some website called Bricklink, which I don't know. This video not sponsored by Bricklink, I promise. But just in like perusing the internet, this seemed to be a fun thing to keep track of. This is a website that I guess sells Lego pieces, and they categorize things as like primarily one of these colors or the others. So I guess there's like 5 pieces that are primarily black, 27 pieces that are primarily brown. Looks like people for the most part. Purple pieces. All right, we get it, sure. So if I were to look at these distributions, that's two things. It's the actual values that it takes, which is the primary color, and then the other thing is how frequently that occurs, either in terms of raw frequency, which is the individual counts. Again, there's 5 black, there's like 21 purple, or the relative frequency, which if I want to find that, it just tells me what proportion of the 224 different pieces are that particular color. How do you find that? You just take the frequency and you divide by the total. So if I do 5 divided by 224, that gives me 0.022, which is the decimal form of 2.2%. So in this class, I'm going to bounce back and forth between talking about percents as like decimals and actual percentages. Percentages are pretty, but remember to actually do your calculations with them converted as decimals. I'll give some examples of that being important later. But yeah, the value, again, a distribution, the value a thing takes, and then how often it occurs, either in the raw counts or the percentages. Fine. So if I ask you to the right, what's the variable and what type of variable is it? Feel free to pause at any point if you want to try to answer or ponder these questions yourself, but I'm just going to roll through this right now. You should recognize that the variable that we're looking at is the Lego piece color, and that's a categorical thing because colors are words and not numbers, right? If I ask what's the best way to graph this, well, we have a couple options, and we'll start discussing some of those now, with one that's very familiar to you, I'm sure. The adult word for it, the adult phrase is, I guess, circle graph, even though everyone knows this is a pie chart from like middle school. And what it does is it displays proportional parts of data for one variable. Remember, this chapter is called one variable data, even though we're going to peek a bit into two variable data a little bit towards the end of this. But for now, it's worth noting that if I have one variable with outcomes that are mutually exclusive, which is to say there won't be any overlap between these things. There's no pieces that are primarily blue and brown, for example. It's one or the other, just like blood type. Well, a circle graph is good for that. Here I have the actual labels for these portions, like they're colored accordingly, obviously, and then on the inside they're given the percents. We could have been given the actual frequencies as well instead of the relative frequencies. That doesn't matter. But in terms of like sketching this out, if you were tasked with sketching this out, I don't think the AP exam would ever ask that of you because Just the format that it is makes that kind of untenable. But for what it's worth, if you think all the way back to your geometry days, consider how like each of these sectors is a fraction of the circle. And if we want to find that fraction of a circle, well, really it's going to be the relative frequency of the entire variables like sample set, right? It's whatever proportion of 224 we're dealing with. So given that the central angle of the circles all add up to 360 degrees, it's just that central angle times 360. So for example, if I look at the red is 4.9% of all of the pieces here. So we would expect the sector to represent 4.9% of the entire circle. You take that, you take 4.9% of 360, you get like 17.5-ish percent. So that's what you'd make degrees. That's what you'd make the central angle. Here is where, again, you got to be careful, because if I do actual 4.9 times 360, I'm going to get like 1,764 degrees, which is obviously wrong. So what I really did here is I typed in my calculator 360 times 0.049. Remember, when you're doing calculations, represent percents as decimals. So the second type of way I could represent one variable categorical data is with the bar graph, our old pal, the bar graph, which you absolutely know, right? Here's an example of a bar graph being represented vertically. The bars are going up. They could also be represented horizontally. We'll see some of them later. And if you think back to our bad stats video at the very beginning, it's important to keep these the same width in this case, because if I were to have some of these bars being fatter than the others, like wider, that could be misleading because that makes it look like they consist of a greater portion of the data than they actually do. A slight detail is to keep these things non-touching, show that there's a gap between them, to show that these categories aren't continuous. That's something that we actually worry about with quantitative data, and that's really like, spoiler, this is what separates bar graphs from histograms. It's again like silly terminology stuff that won't be hard to remember once you kind of have solid exposure to these, but for now it's worth noting bars should be vertical or horizontal, same width, not touching. Also label these bad boys, right? A good thing to have is a title for your graph, and like your science teachers are probably going to harp on this as well, that you want a title for your graph, you want to label your categories and your axes accordingly. Also in the bad stats video, we looked at some breaks, some truncation being used very deceptively in order to make it look like the gaps between some categories were larger than they actually were. So that was bad practice, right? But it doesn't mean that truncating the y-axis is always a bad idea. Like, if all of these were 1,000 greater, like if this is 1,005 and this is 1,035, if I tried to graph, or 34, whatever, if I tried to graph that graph with bar graphs, the bars would be so close to each other that the graph would be practically useless because we wouldn't be able to distinguish how close the bars actually are, or like what the differences actually are from each other. So at that point, we'd probably truncate the y-axis just to say like, all right, the difference here is really from like 5 to 34. It's like a difference of 29. This is a difference of, 7, yada yada. It's all about the presentation. So note that truncation isn't a terrible idea, depending on the data set and also depending on how you do it. So here the y-axis is the frequencies. We just have the raw counts. But a question for you. If I did want to represent the y-axis as the relative frequencies instead, the percentages of the whole, if I asked you, how would converting that actually change the graph? Well, if you're done thinking about it, I'll just straight up show you. Oh, look, pretty much nothing changed. Not really. All I really did is, like, again, think geometry. I scaled down the y-axis by a factor of 224. I just divided everything by 224, and that gave me the actual percentages instead of the raw counts. So we can see the bars are all the same heights relative to one another. Any slight differences we see between, here it is again, the frequencies and the relative frequencies is just due to rounding on the y-axis and rounding the relative frequencies. But like everything is still the same height relative to one another. We still have, if one value is double the other, that's going to be manifested in the actual frequencies y-axis versus the relative frequencies. So to answer this question, nothing's really different at all. Keep that in mind. And that kind of just means that there's no wrong way to do a bar graph this way. So if I were to look at two variable distributions for a moment, the best way to represent this is with what's called a two-way table. What they do is they display two categorical variables of a data set, either with frequencies or relative frequencies, depending on what's best for us. So what I actually did is I went on Pew Research, and I looked this up just because why not? The actual proportions are out there, like the percentages of teens that use one platform over another versus adults that use one platform or another. it's out there. But if I want to pretend that I used a sample, I tried to stick as closely to the percentages as possible, so feel free to actually consider this like real data. If I have 6,050 users aged 13 and older, and they were asked their age as well as which social media platform they prefer, this is how I could dictate that data. There were, out of the, again, 6,050 people, 1,536 of them were teens who preferred TikTok. Shocker, right? No surprise at all. 50 of them were adults who preferred Snapchat, and yada yada. So if I were to consider the two variables in this case, the row variable is the preferred social media platform, right? Each row is a different social media platform. Voice crack. Feel free to make fun of me for that later. The column variable is the age group. There's only two. There's teens and adults. Even though when I say two-way table, yes, there's rows and columns, but I could have more than two columns here. Like, I could have different age groups of, like, children, adults, and then, like, elderly or whatever, right? Children, middle-aged, and elderly. It doesn't matter. But for now, what we could do is we could talk about how to actually use this to answer questions like the following. How do platform preferences compare amongst all social media users? And does there appear to be any significant differences in preferred platform between the age groups in the study? Well, again, if you're not just passively listening and you're actually thinking this through, it's not super obvious just looking at these numbers what the answers to these questions are. For a couple of reasons. One, like, more than 3 times as many teenagers were polled, almost 4 times as many teenagers were polled as adults, so that makes it hard to compare raw counts. Like, yeah, there's more teenagers on, like, other compared to adults, but is that because there's more teenagers, or because they actually have other preferences aside from adults? Hard to say. And I guess we could look at things in, like, a 4-ish to 1 ratio, sure. But it makes it so that the raw counts aren't totally useful on their own. So we're going to handle this one question at a time, and we're going to look at what additional new graphs we can look at would best help us to answer these questions. So let's look at some graphs. There is something called a multi-bar graph, which compares the distributions of a categorical variable across 2 or more groups using adjacent bars. So what does that look like? Imagine this. Imagine I take the TikTok bar for teens and the TikTok bar for adults, the 1536 and the 100, and I line them up next to each other. That makes it a pretty stark difference, right? I could do the same thing with Instagram and YouTube and Facebook, Snapchat, other, and it looks like teenagers outweigh adults in pretty much every category except Facebook. Again, no surprise. But that's still not super helpful because we know there's more teenagers in the study. So yeah, of course, the teenager bar is going to overcome the adult bar a lot of the time. So rather than let our categories be the social media preferences and compare the teens versus adults, what if we do it the other way? What if I instead swap the categories and I swap the x-axis? Instead, I'll let the x-axis be the age groups, and I'll let the categories be the social media preferences. So now, this is better for comparison. I can see among teens the preferred social media. Whoops. Let's dial that back. I can see amongst teens the preferred social media platforms. I can see that TikTok dominates. I can see that Facebook and other aren't super popular. Other isn't popular in either case. And I don't know if that consists of, like, Truth Social, like Threads or whatever. I don't know what people are on these days. Clearly people are on TikTok these days, right? Or at least teens. But being able to compare within categories is a lot more helpful than being able to compare, amongst these categories, I should say. So both of these are options where kind of like I swapped the row and columns places in the graphs. Like I got version 1, version 2. But these are both multi-bar graphs looking at the same data. Here you can see that amongst adults, YouTube is more popular. YouTube is pretty popular amongst teenagers too. But then Facebook has a lot more popularity amongst adults than teenagers. Now we actually have the visual to demonstrate this as well. Maybe you're still not content with that though, because there's still the notion of more adults than teenagers. So I said that backwards. More teenagers in the study than adults. So let's keep that in the back of our mind. What if I want to specifically answer question 1? How do platform preferences compare amongst social media users? This gives no regard to the age groups. It doesn't care who's a teen and who's an adult. So in this case, what we can do is we can look at the marginal distribution of the data. Marginal distributions examine one variable for all individuals in the data set, and it does this by combining or pooling the frequencies for rows or columns. Pooling is a word you're going to see a lot in the future. Or not a lot, but you're going to see it again. And it more or less just means like combining the data sets. So imagine this. Imagine I am running for president of the United States. And I get my whole like marketing committee together, and they're like, all right, so here's how you're polling, sir. Calling me sir is funny in my mind. Here's how you're polling. Like, you're polling like this percent among males and this percent among females. Like, okay, cool. Can you just tell me how I'm polling overall, though? Because I know, like, electoral college stuff aside, I just want to know what proportion of everyone, what proportion of voters I'm doing well with. So sometimes it doesn't necessarily help to break things into two categories along the lines of a second variable. Sometimes you just want to look at stuff overall. So in this section, if I'm looking at stuff overall to compare social media usage amongst all users, then I should be looking at the total column. So let's suppose I do that. Let's suppose I take all the teenagers using TikTok, all the adults using TikTok, the 15, 36, and the 100, and I just look at them combined, the 16, 36 now. That's all the users who use TikTok. Same with Instagram and YouTube and Facebook, Snapchat, other. And even better is to look at these in terms of relative frequency, which, again, is pretty synonymous with percentages in this case, percentages of all the users. If I do that, then I have a lot more of an appealing visual that I can kind of look at and compare more easily. And again, like this 27.04% came from the 1636 divided by 6050. It's the frequency divided by the total number of people in the study. That gets me something like 27%. And again, if I were to do any work with this, I'd probably want to represent it as 0.2704. And again, final step, probably put it together in a visual. We have two options that we talked about. Now that we have these frequencies, or relative frequencies, I could throw them in a bar graph. I could throw them in a pie chart, circle graph, whatever. Here I put my bar sideways just for emphasis to say like, hey, we could do that. And I made my y-axis the relative frequencies. Again, for comparative purposes, I can see like YouTube and TikTok are about as popular overall amongst all of its users, even though we know that if we do a demographic breakdown, then that popularity won't be equal amongst the different demographics. Not at all. That's also reflected in the pie chart here. I got 27 and 27. Everything else is clear as day because we gave ourselves a nice visual. And that's the entire point of a graph. Like, if we can look at it and make deductions about the data just by like a quick glance, then we've made a successful graph. Things in the last video did not successfully do that. So question 1, answered. How do platform preferences compare among social media users? Now we have a good idea. Question 2, does there appear to be any significant differences in preferred platform between age groups in the study? All right, now we're talking teenagers versus adults. And to have a better idea here, we already kind of noted like, well, it's hard because the number of adults is not even close to the same as the number of teens. It's almost like a 4-to-1 ratio, right? So what do we do about that? What we could do, and if you've thought this through, you may have known without knowing the correct vocab for it, that looking at the conditional distributions is a good idea. What that does is it lets us examine the proportions of variable x, which is to say one variable, in the context of variable y. So let's just look at one variable in terms of the other, proportionally speaking. So I want to either look at the proportion of rows or columns in this. I am comparing teens to adults in this because that's what the question's asking. So I'm going to look at the percentage of teen preferences versus the percentage of adults preferences. How do I do that? Oop. Okay, cool. We got past that already. Sorry. How do we do that? We ignore the totals, and I look at the teen column and the adult column separately. Raw counts aren't doing it for us, so like we said, let's look at them proportionally speaking. I am taking 32%, or I should say this 32% doesn't represent 32% of everyone. This is not 32% of the 60-50 people in the study. It's 32% of teenagers. And that is the 32% of teenagers that prefer TikTok as their social media platform, like their go-to platform, right? This 4% down here is representing 4% of adults in the sample prefer Snapchat over anything else in the study, right? So let's make sure we understand that well, because if we do, then we know how to graph this. We can graph it in such a way that, like, I mean, this is very similar to what we had before. It's just kind of scaled similarly now. We scaled the teenage data down, and we scaled the adult data up. If you were to go back a couple minutes in the video and look at these, like, this is just a bigger version of what was on the previous page, maybe 2 pages ago. Because when we look at them relatively speaking, that puts them on equal ground, and it makes it so we're not exactly comparing apples to oranges. So something that's clear here is that YouTube usage is way more prevalent amongst adults than teenagers. TikTok usage is way less preferred amongst adults, and it actually doesn't look like there's too much that are equal. We We have a lot more adults exploring other platforms than teenagers, proportionally speaking, in the study, right? But other than that, I think the big picture here is that looking at a multi-bar graph with proportions, with conditional distributions, gives us a lot better of a visual than what we've dealt with previously. Fourth and final one, and I'm just laying this all out there for you. If I were to take those bars from the previous page and stack them, that gives us what's called a segmented bar graph. It stacks the proportions of each category of one variable, and it lets us compare these two stacks to each other. Or again, if there were 3 different age groups, I'd have 3 different segmented bar graphs, and I'd be able to compare them to each other as well. Specifically, it lets me compare their conditional distributions. So this was still the same data from the previous page. I'm just graphing it, and especially when they're stacked, maybe it's about as useful as the multi-bar graph, but like, at any rate, it lets me answer question 2. Does there appear to be any significant differences in preferred platform between age groups in the study? Yes, you betcha. That's pretty clear. I got one more thing to talk about in great detail. That's the notion of association. And it seems mostly common sense, but we're going to kind of put a fine point on a definition here. So association is a relationship between variables in which knowing the value of one variable helps in predicting the value of the other variable. And if 2 things aren't associated, then they are called independent. So what does that look like in context? Well, let's give you an example to kind of hopefully make some sense of it. Gallup asked a random sample of 2024 American adult cell phone owners which type of cell phone operating system they have. iPhone, so iOS, Android, or something else, right? The results broken down by age group are seen to the right. Here they are. We have another 2-way table. This time it's 3 by 3 because there are actually 3 different age groups here. Everything's lumped into iPhone operating system, iOS, Android, or other. Cool. And we can see that all the totals of rows and columns all add to the 2024 people who were in the study, right? So if I ask, again, I recommend taking a second to maybe pause this, look at what you're looking at here, read the questions, consider what the answers might be, and then come back to check. But you pause at your own, as you will. I'm just going to fly through this. So what type of graph are we given? That is a multi-bar graph. You only have to go a couple pages back to remember that. Why is this a good graph to use? Well, I think it's a good graph to use, and I think so because it allows us to compare proportions. Notice the y-axis is percent of operating system types across groups. This is particularly useful when the sample size is either the rows or columns. They're not the same. But remember, proportions are good for comparing, or I should say they're better than frequencies, raw frequencies, for comparing, especially when the totals are not the same. That makes it very hard for us to compare quantities. But here we can kind of pick up on some like patterns here between the different age groups. So if I say explain why the variables phone operating system and age group are associated rather than independent. Remember, association just means if I know something about one of the variables, I can comment on the other. So for example, if I know that someone is in the age range 55 plus, I know their age group. Does that tell me something about the other variable, the phone operating system? Absolutely it does. What does that tell me? That tells me that old people are probably not going to be dealing with things like iOS and Android. To be honest, they're probably not using smartphones as much, so they have different operating systems for their phones. And you can see that reflected in the much larger green bar of other. You can also see like the younger adults are much more inclined to be using iPhone than the like middle-aged adults, who I guess are also opting towards other at greater frequencies, right? So yes, it is absolutely the case that knowing an owner's age group greatly increases the likelihood that we can predict their phone operating system. Sure. And that begs the question, like, what if we couldn't? What if they weren't associated? What would the multi-bar graph of independence actually look like? And if you're thinking like, well, everything's the same, it'd be like 33%, 33%, 33%, all across the board. Not really. You're close. You're onto something, but not really. What that would indicate, independence would indicate, is that knowing someone's age group doesn't tell me anything about their cell phone operating system preferences or habits or whatever, right? So it could still be the case that like, here's the split between iPhone, Android, and other, but if that's true for 18 to 34-year-olds, that would have to be true for every other age group as well in order for there to truly be no association between the two variables. So independence would look like, more or less, the same set of bars for each age group. So again, not 33.3% across the board, but if I took this or any set of 3, and copy pasted for the different age groups, that would tell me that they're independent, because it doesn't matter what age group they are. The likelihood that they use one operating system over the other is identical. I got one more thing for you, just for funsies. In both 2019 and 2024, Pew Research asked samples of adults how they most commonly get political and election news. Their responses are below. So these are actually like, I screen capped and pasted these from actual like news articles, both from Pew. It was weird to see 5 years apart them asking more or less the same question, using different types of graphs, right? And how the answers changed over time too. So take a second to digest this maybe. Note that, I mean, this is a pie graph, this is a bar graph, right? But also like the way that they categorized answers changed a little bit in that 5-year span. This is right before the pandemic, remember? And they're both like right before election cycles, so times have changed. Things have made people feel certain ways. And like technology has evolved too. So here you see like TV, just broken up into different categories, as opposed to in 2024 when they lumped it together and just said TV. You can see things like podcasts make an appearance here, but they don't make an appearance here. No answer was the like default final option here, but over here some other way was. So it's worth noting that like some things change, but they're still very comparable. So what I did is I threw this all in Excel. I kind of like, from the 2019 one, I combined the TV things. That gave me something like 40, I guess I should do math, 45%, right? Which better let me compare 2019 TV preferences from 2024 TV preferences. And I kind of clumped everything in these 6 categories. I considered no answer in 2019 to just be other, right? And now suddenly I have a graph, and I could see how trust in different media sources has changed over time, or at least preference in media sources has changed over time. This is not like, I mean, this is not a question from a textbook. This is just something that I independently explored, and like now I have a pretty good data, and I have a pretty good feeling of like how social trends have impacted trust in politics and election news over time, which I think is pretty interesting. So if I actually ask you to compare these things, and this will be the last thing we do, again, take a second to pause it and think about, like, I think I wrote 3 sentences that would be good. Like, what are the top 3 things that you notice in terms of differences between the 2019 and 2024 news preference graphs? First of all, there's definitely an association, right? Like, we can see that if we know what year the poll was taken, we have a lot more information regarding what someone's preferred political and election news source might actually be. We know it's much more like, or I should say much less likely to be television in 2024. And it's much more likely to be, something else? We can comment on that in a second. Something else I can note is that TV and news sites and apps and social media are still the top 3, right? Green, orange, blue, green, orange, blue. Though TV is the thing that has lost the most popularity over time. Something else is that radio also decreased. Radio and TV are considered kind of the traditional media, like the things that our parents watched. And that probably corresponds with the rise in other news sources. I mean, other could be a whole gamut of things. And we know people, that was around, the pandemic was around the time that people were looking for alternative news sources and searching for alternative media. So this kind of tracks. And it's interesting to see. Guarantee that's a scam phone call. I'm not redoing the video because of that. Sorry. We can see how things have changed over time. Cool. Great. So I think I'll leave that there for now. Thanks for watching.